What's going on? What is going on? We already got the dabs starting. Look at the new setup. Probably sounds better. What up, Bob? What up? Yeah, I just moved a few things around. Same mic, but I think the positioning is a little bit better in terms of audio, so it's a little bit more consistent instead of being all over the place. So what do we think about the lesson 10-5? A little crazy, easy peasy. What do we think? Just finished washing it, so then you have an opinion. And what is that opinion, Bob? It was good. Yeah, that's it, it's interesting that it seems like it's a lot of steps because it does. It's more of like if your brain could categorize what you need to do, it would be set up a system. So that's the first step. Solve the system. That's the second step. But if our brain has a hard time either one creating that system or two solving that system, that's where we're going to get a lot of issues. And that's where, it can seem like there's a lot going on because of that. So yeah, it is a lot. It is definitely a lot that's going on with those problems, which is why I spent a whole lesson just on being able to do that. Anyone else? But hopefully it didn't seem too overwhelming. Hopefully it didn't seem too overwhelming. Cool. Alrighty. Let's go ahead and let's take a look at a few of these. So the first one, it says, given the two values in the geometric sequence, find the explicit formula for the sequence. So let's look at number one. On number one, it gives me the fifth term. Not too much space. Well, you could write your own space, can't you? Look at this. I gave you the worksheet. You can be like, boom. Look at how I solved that problem. Look at all that space now. Da 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 da. So what do you think, Bob? Did I solve your issue? I think I did. All right. And then the third term is going to be 108. Oh, man. I felt really sassy there. Okay, since I know it's geometric sequence, I know that it's going to be the this formula. A sub n equals my first term times my common ratio to the n minus 1. So for both of those terms, I have to find two values. I need to know what my common ratio is. I need to know what my first term is. So that's the two things. So since I need to know two things, I have to set up two equations to be able to solve those two things. So then my two equations are going to be my a sub 5 equals a sub 1 times r to the 5 minus 1. Now, how did I get that? That's my n. That's my a sub n. So I basically just plugged it in. My a sub n, and then my n is 5, so I plugged that in for 5. Now simplifying that, 3,888 equals a sub 1 r to the fourth. Questions on how I set that up? Let's try that with the next one. So same idea, my a sub n equals my first term times r to the n minus 1. And so that's going to give me 108 equals a sub 1 r squared. Questions on that? So the term that's the same on these is my a sub 1, so I can get those by itself. So divide both sides by r to the fourth, and then divide both sides on this one by r squared. So then I'm going to get 3,888 over r to the fourth equals a sub 1. And then on this one I get 108 over r squared equals a sub 1. Now that the a sub 1s are by itself, well, since they both equal a sub 1, I can go ahead and set those equal to each other. So I'm going to get 3,888 over r to the fourth equals 108 over r squared. Now I just want to solve for r. So the first thing I can do is I can multiply both sides by r to the fourth. Now technically I could also multiply both sides by r squared, but if I did that, I'm eventually going to have to divide by it anyways, because now these r's here, those are going to cancel out. So I'm going to get 3,888 equals 108 r squared. So I have 4 r's on top. I have 2 r's on the bottom. 2 of those r's are going to cancel out. Then divide both sides by 108. And you know what? I'm going to get out my calculator for that. Shout out to this really cool app on your phone called Calc84. It's like having a TI-84, guys. Sponsorships. And you're going to get 36 equals r squared. Square root both sides. You're going to get 6 equals r. Now, technically, I could say plus or minus, but I know that it's not going to be a minus because it's remaining positive. So if it was like switching off, then I could say it would be a negative. So now if I know that my r is 6, I can plug it into one of these equations, either this one or this one. I'll plug it into the bottom one. So, or sorry, the one that's on the right. So 108 over 6 squared, that equals my a sub 1. So 108 divided by 6 squared, 36. My a sub 1 equals 3. So that means my formula is going to be a sub n equals 3, so my a sub 1, times my r to the n minus 1. So that right there is going to be my generic formula. Now, just to put that into perspective, I know it's a lot that's going on there. Technically, this is step 1. Then all of that, including that's step 2. So all of this in this big bubble and then that's step 3. So technically, it's 3 steps, but it's a lot that goes on. It is a lot that goes on. Yeah, the solving equations is a lot. Okay, any questions on this one? So that first step is establish a relationship. That was step 1. Step 2 was to find those values in the relationship. And then step 3 was to write the generic function. Cool. Let's go on to number 3. So this one is an arithmetic sequence. So given my 2 terms, I have a sub 18 equals 44.3 and a sub 33 equals 84.8. Could I do number 2? I'll go back to number 2. So for this one, since it says arithmetic, I know that my formula is going to be a sub n equals my first term plus n minus 1 times my common difference. So the 2 values that I don't know that I need to find are going to be those 2. So the first step, set up the relationship. So my a sub n equals my first term plus, and then 18 minus 1 times my common difference. And on the other one is 84.8 equals my first term plus 33 minus 1 times my common difference. So this is just going to become 44.3 equals a plus 17d. And here's going to be 84.8 equals a plus 32d. So now it's a system of equations, right? I needed to find 2 values. I needed to find my first term and my common difference. And I needed those 2 equations to do that, so I set up my 2 equations here. So now as a system, I can combine them together. So 44.3 equals a plus 17d. And then here is 84.8 equals a plus 32d. Now the different strategies to solve these, because these are both linear, the different strategies are going to be elimination or substitution. I think elimination is a little easier. So if I multiply this entire equation by -1, this is going to become 44.3 equals a plus 17d. And then this one's going to be negative 84.8 equals negative a minus 32d. Now let me adjust this because I know my camera's going to be blocking it. Yeah, I'll go back to number 2. So now I can add these equations together and create a new one. So this one, if I were to add these together, so 44.3 minus 84.8, so that's going to be negative 40.5 equals, now those cancel out, and then 17 minus 32 is going to give me negative 15 times my common difference. To get d by itself, you're going to take the negative 40.5 and divide it by the negative 15. And so your common difference is going to equal 2.7. So now I need to find my a value. So to find my a value, I need to plug it in into one of these. And I'll plug it into the top one. So I get 44.3 equals a plus 17 times 2.7. So that means I need to minus the 17 times 2.7 on both sides. So 44.3 minus 17 times 2.7. And that's going to give me my a value of negative 1.6. So now that I have my two values, now I can just plug them into my formula. So it's going to be a sub n equals my first term plus n minus 1 times my common difference. Comments or questions on that? Cool. Let's go back to number 2. So it's the geometric sequence. So my formula for the geometric sequence is a sub n equals a times r to the n minus 1. So my two relationships, my first term, actually this one might be a little easier because if it gives me a sub 1, a times r to the n minus 1, well, it already gives me my a sub 1. I already know what this is. So this is supposed to be negative 2. So I know that negative 2 equals negative 2 times r to the n minus 1. Now, in this instance, the problem here, though, is my n is 1. So I get negative 2 equals negative 2 times r to the 1 minus 1. Well, that goes to 0. So 2 times r to the 0 power is 1. Okay, well, that's a wash. That's a true statement, but that's a wash. But I can use that a sub 1. If I know a sub 1 equals negative 2, I could use that in my next one. So I know that negative 512 equals my a sub 1 times r to the 5 minus 1. Because it already gave me my a sub 1, so I plugged in my first term into the formula. I don't know what my r is. I know my r's look like these. I apologize. It's harder to write them on this monitor. But now I just need to basically solve for r. So I get negative 512 equals negative 2 r to the 4th. Divide both sides by negative 2. So 512 divided by 2 is 256. And then, to get r by itself, you're going to do the 4th root. So the 4th root is going to be 4. So now that I have my a sub 1, My a sub 1 is negative 2, and I have my r. I can write my generic equation. A sub n equals negative 2 times r to the n minus 1. Comments or questions on that? Okay. Let's move on. So number 4, it says, given the explicit formula for an arithmetic sequence, find the first 5 terms of the problem. And then also find the first 5 terms and the term named in the problem. So find the first 5 terms and find a of 34, basically. That's what it's asking. So for number 4, if I know that a sub n equals negative 11 plus 7n, that means a sub 1 equals negative 11 plus 7 times 1. A sub 2 equals negative 11 plus 7 times 2. A sub 3 equals negative 11 plus 7 times 3. A sub 4 equals negative 11 plus 7 times 4. And a sub 5 equals negative 11 plus 7 times 5. So you need to find what all of those are. And I'll let you guys do that. I'm sure you guys know how to multiply and add things together. I have confidence in my honors integrated 3 class. And then it says find a of 34. So a of 34 just means you plug in 34. So you get negative 11 plus 7 times 34. Comments or questions on that? No, you're not. No, you're not. You are amazing, sir. Okay, any other questions on 4, 5, or 6? Because you're just going to set it up basically the same, except number 5, you have to find the 39th term, and for number 6, you have to find the 27th term. Dude, I have like the hiccups. It's the worst. All right. The next one says, given the explicit formula for the geometric sequence, find the first 5 terms and the 7th term. So this is basically the same thing, except my formula is going to be a little different. So for my a sub n, so my a sub 1 is going to equal 3 to the 1 minus 1. My a sub 2 is going to be 3 to the 2 minus 1. My a sub 3, 3 to the 3 minus 1. A sub 4 is 3 to the 4 minus 1. A sub 5 is 3 to the 5 minus 1. And we just got to simplify that. And then the 7th term, a sub 7 equals 3 to the 7 minus 1. So you just need to simplify those, and those would be your resulting answer. Comments or questions on that one? All right. So moving on. 9 through 14. So for number 9, you get log base 6 of 1 over 36. And so that's going to be log base 6. And then with that 1 over 36, I can replace that as 1 over 6 squared. I can move that exponent to the top. So you get log base 6 of 6 to the negative 2. Those would cancel out, so I'm left with negative 2. Questions on that one? On number 10 and 11 are going to be very similar. Actually, 10, 11, and 12. So I get log base 1 over 6 equals 216. I don't know what that's going to equal, so if we remember, whoops, there's no equal sign here. I don't know what this equals or how it simplifies, so I can say it equals some number. So we just say it equals x. So then that means that I can take base 1 over 6 to both sides. 216 equals 1 over 6 to the x. Now that it's an exponential equation, I just need to make the bases the same. So 216 is the same as 6 to the third. I can move the 6 to the top here, so I get 6 to the negative x. So you get 3 equals negative x. And so x equals negative 3. Now, just remember, we can't really say x equals negative 3, even though I solved for this equation, because if you look at the original problem, there was no x there. So it's just easier if we write it out and say log of 1 over 6 of 216 equals negative 3. This same way of doing it, you would do for 11 and 12. Okay, number 13. Log base 2 of 3 to the log base 3 of 2 power. So the 3 and the log base 3 are going to cancel out, so you're going to get log base 2 of 2, and those would cancel out, and you're left with 1. And number 4 is very similar. Or 14, number 4. Well, that concludes. Can I do number 12? Number 12. So log base 4 of 8. I don't know what that equals, so I'm going to say it equals x. So we're going to take base 4 to both sides. And so I get 8 equals 4 to the x power. So 8 can be rewritten as 2 to the third. 4 can be written as 2 squared. Now that the bases are the same, I could set the exponents equal to each other. And so divide by 2, you get 3 halves. So your answer is going to be 3 halves. My doorbell. No problem. Did we have a good weekend? I didn't ask. Did we have a good weekend? Was it restful? Probably not eventful, but at least was it restful? Good. I'm glad, Bob. I'm glad we had a good weekend. Pretty chill. That's good to hear, Christian, and it's good to hear from you, man. That's awesome. I'm glad it was chill. Anyone playing any cool games lately? I hear that new Mountain Blade 2 game is pretty chill. Fortnite? I could just never get into Fortnite. Never. Doom, that new Doom game, dude, you need like a crazy, crazy graphics card to be able to do that, right? Number 11. Log base 1/5 of 625 equals some number that I don't know. You can't with Battle Royale games. Are you saying me personally or just in general? So you get 625 equals 1/2 to the x, or 1/5 to the x. So this is going to be 5 to the 4th power. And then moving that up there, you get 5 to the negative x. I get super angry when I play Battle Royale games. So my answer is -4. I like that new Call of Duty Battle Royale game. That's pretty good. But like I said, I get jittery, man. I get jittery quick. But it's pretty fun. I didn't like Fortnite at all. The whole build, jump, build, shoot, build, build, chop, shoot, jump, build, shoot, jump, shoot, build, jump. It's like, yes, you can do that. You can do that, Howie. All right, cool, guys. Well, this does conclude this lesson. Within the hour, I'll have 10-6 uploaded, so we'll be ready to go with that. Other than that, we're all set. If you guys do come across any questions on this, just go ahead and post it in Discord, and I'm more than happy to be able to help you guys. You're welcome, Bob. Have a great day, and I'll see you guys tomorrow.